Welcome everybody, my name is Tomasz Strawski. I will be talking today about using real-time SQL monitoring. So, couple words about me. I work for database consulting. I have over 13 years of experience in PL/SQL development. 5 of them I worked with performance tuning. I'm data warehousing, performance tuning, and Apex technology enthusiast. If you want to contact me, there are my contact information, email, Twitter, LinkedIn. You can also read my and many other interesting articles in blog.dataconsulting.pl. Okay. The goal of today's presentation is to show you how to monitor performance of your SQL statements. In this presentation, I will show you the story of how to monitor your SQL statements. I will show you what monitoring options you have. I will show you how to find historically monitored statements. I will tell you also about parameters associated with SQL monitoring. Finally, I will show you some more examples of SQL monitoring. So let's see how to monitor your SQL statements. I will show you this on real world like example. So meet Benjamin. I will tell you about him and his performance issue example. Except for his strange habit to wear a Santa Claus hat all the time, just like the Christmas were all year long, he is a SQL developer and very savvy one. Once he had to prepare SQL report, but prepared SQL was taking long time to finish, which was irritating. And when developer is irritated with the performance, the user would be irritated much more. So Benjamin started to think, what can he do with this query? The query, as you can see, wasn't very complex, but the performance was bad. He decided to monitor this query. He forced SQL monitoring, adding the hint to the query. He looked then at the details of the query in Enterprise Manager, and he was able to notice that in this report, the estimated rows and rows actually returned by operations differs. So that could be the cause of the bad performance. Often wrong assumptions made by optimizer regarding number of rows to process lead optimizer to choose not optimal plan and could cause performance issues. Wrongly estimated rows are often caused by stall or missing table statistics. So Benjamin checked the statistics and noticed that something is wrong, something is missing. That's why he gathered statistics on sales to table and ran the query again. And this time it was much faster. It seems like a problem is solved, but he decided also to verify this in SQL monitoring report. As he can see, the estimated rows and the actually returned rows by the operation now matched. So the problem was solved. The report was fast, and the life was great again. That is the story of Benjamin, and that is how we can make our life easier with help of SQL Monitor. So let's see furthermore into the details of monitoring options. The easiest one is to use Enterprise Manager, just like Benjamin did. Enterprise Manager is a graphical interface tool that exposes the SQL Monitor to us, and you can find it in Performance section and in Monitored SQL list. You will find there all the currently monitored SQL statements, and if you choose the SQL ID you want to verify, you can see detailed report of the statement execution. The report is divided in a few sections. On the top left-hand side of the report, you will find some general information regarding executed statement, like SQL text, like execution started time, and so on. In the middle of the top of the report, you will find time and wait statistics, like duration of a query, like used CPU, used database time, and activity %. When you hover your mouse over these bars that are showing time, and you will find some more details. The tooltip will appear and provide you with some more detailed information. And on the top right-hand side of this report, you will find informations regarding I/O used when executing this query, like buffer gets, like I/O request, and I/O bytes. In the bottom of the report, in a Plan Statistics tab, you will find execution plan of the SQL statement. You will find there all the operations that are in the plan and associated and objects accessed by these operations. Also, the lines that are currently executed are marked in a light green highlighted in light green color. There are more interesting information also provided, like filtering predicates for operations, like join statistics, and so on. You will also find here execution plan node. Furthermore, as we already seen, you will find here also informations about estimated rows by the optimizer for each operation and the actual rows returned by each operations. At this point, from my experience, and as Benjamin case showed, it is often one of the first place to look in the plan to mismatch, because this could lead to a problem. Going further to the right-hand side of the report, we will find more detailed informations regarding memory used by each operation, regarding usage of temporary table space of the operation, and IOs. Also, when you hover your mouse over the report bar, you will find a tooltip with more detailed information. And finally, you will find information regarding activity percent, which column is also one of the first place to go and see for the hotspots in the SQL statement. Here you can find a bottleneck of your statement. Additionally, when you look at the report, you will find some more details regarding metrics and SQL activity and full SQL text in the report. So that's what you can see in the Enterprise Manager. But sometimes it is not possible to obtain Enterprise Manager access for SQL developer, or maybe there are some other cases that you cannot use Enterprise Manager. So there is additional option that allows you to view results of SQL monitoring. It's SQL API. So you can use DBMS SQL Monitor package to obtain monitoring information. Report SQL Monitor list allows you to get a list of currently monitored statements, and report SQL Monitor function allows you to get details of monitored SQL by SQL ID. And here is an example of report produced by this function in a text mode. Here you can also find at the top of the report some general informations. Then you will find some global statistics like elapsed time, like IOs. And at the bottom of the report, you will find execution plan with all operations contained in the plan, all the objects accessed in the plan with estimated rows, actual rows, and so on. Also, in the plan is shown which operation is currently executed on an ID column. At this point, maybe it is also worth to notice that real-time monitoring allows you to see what's happening with currently executing statement, and you don't have to wait until it finish. You can verify and find the issues in the statement during the runtime and decide, for example, to terminate the query and run it again when the problem is fixed. Okay, and there is also one more possibility that gives you a SQL API. You can directly query performance views, which are part of SQL Monitor, and that is $SQL Monitor and $SQL Plan Monitor. At first, you will have to find unique key for SQL ID, and then using that key, you can run your customized query against $SQL Plan Monitor. Sometimes it could be more useful to query these views directly. Then in compare running functions that returns you a float value. So sometimes this could be also very convenient solution. And here is an example of the output. Okay. So far, we have seen how to monitor SQL statements in real time, but it is also possible to browse through monitored statements in the past. For example, you can imagine that during night hours, there was an issue with a query on a production, and you can investigate this issue by checking historically monitored SQLs that were saved in AWR. So you can access it also through the Enterprise Manager. You have to just choose a proper window and look for your SQL that caused performance issues on the list. This is also possible for SQL API. You have to just find report ID for SQL that you want to verify. And you can do it querying DBA hist reports table. And there is report ID. And we provide this report ID to report repository detail function from the DBMS auto report provided package. And there is an example of the output. Okay. SQL monitoring parameters. So let's see the parameters that controls SQL monitoring. To be able to monitor your SQL statements, you have to have two parameters set. The first one is control management pack access have to be set to diagnostic plus tuning, which means that this requires diagnostic and tuning pack options in the database. So this is you have to keep in mind that these are extra paid options but are required to run SQL monitoring. Also, the statistics level has to be set to typical or all. SQL monitoring takes place automatically. By default, SQL statements that has consumed at least 5 seconds of CPU or I/O in a single executions are monitored, and also statements that are run in parallel. Additionally, you can force monitoring using hint, and this is very convenient way of monitoring SQL statements, very often used from my experience. And there is another options that you can force monitoring certain SQL, providing SQL ID in set events command. So that is in short how SQL monitoring looks like in Oracle database. Now let's focus on some examples. And here we have an example of business logic. It checks if there are some rows in a sales to tables that satisfy some filtering condition. If there are some rows, then the code do something, otherwise do something else. So let's see how the results of monitoring of such business logic looks like. As you can see, it consumed over 4,000 buffer gets, and the table access full operation returned nearly 1 million rows to satisfy this this check. So how can we make this query perform better and use less of resources? The easiest answer is to add a predicate rownum equals 1. Actually, in this situation, it doesn't matter if just one row or many rows would satisfy this condition. So if one row satisfies it, it's enough. So let's check the results. And as you can see, there are huge difference in buffer gets 4 versus over 4,000. And now the table access full command returns just one row. You can also notice that in the plan there is another operation count stop key that prevents fetching all the rows from when the table access full. Okay, so let's do a quiz. Let's assume that we are creating a table with million rows as this create as table select. So we've got number column ID and some varchar columns, date and systems and timestamp column. Let's modify ID column and set it not null. Then let's create an index on the ID table and gather stats on this table. Now let's run the monitoring of a query that returns one row with ID equals 100 and see the results. As you can see, that there was just 4 buffer gets and the query used index and performed pretty efficient. So let's get to our question. When we modify this query and change the where clause and change the predicates to ID plus 0 equals 100, will that query use the index on ID column? I will give you 15 seconds to think about it. What could be the answer? Yes, I don't think so. Syntax error. Let's check the results. So let's monitor this query. And the answer is number B, I don't think so. As you can see, the query used over 8,000 buffer gets and accessed table full. So the moral from this question is that you have to be extra careful when passing arguments to a function. This example was simplified, but we can imagine that, for example, function add-mo and mons are very commonly used, and providing column as an argument to this function could lead, for example, that index will not be used. So this is something that we have to be careful about. Okay. Let's go to the quiz number 2. Here we have create table statement. So we create very similar table with ID number column, with column 1 to 3 as a varchar and column 4 as a date. We create index on column 1, the varchar, and we run a query that filters out row where column 1 equals 100. Let's assume there are 5,000 rows in the table. Will this statement use index on a column 1? Yes, I don't think so. Let's take some time to consider. And so let's see the results. So it seems like answer B, I don't think so, is correct. The query does not use index and do a lot of buffer gets. So what's happened here? How can we fix it? We can explicitly convert the predicate 100 to the data type of column 1. So make it char. And when we look at the results, we will find out that now the index is used and buffer gets are at much lower level. So in this case, we have to be very careful about implicit data type conversion, because this could lead to also issues with the performance and causing the query not using index. Okay, so to sum up, real-time SQL monitoring is an effective way of monitoring your SQL statements. You can access SQL Monitor through the Enterprise Manager and SQL API. You can monitor your current SQL statement as well as historically run SQL statements. I think you have to keep in mind that SQL monitoring requires tuning pack and diagnostic pack. And if you want to read some more regarding SQL monitoring, I would recommend you a good article by SQL Maria regarding to SQL monitoring. I will refer you to SQL tuning guide, ORAC documentation, and documentation of provided system packages. So if you have any question now, feel free to field any question.
I can't see any questions in the chat.
Okay.
Thank you so much for your presentation.
No more questions. Thank you very much. It was a pleasure to present at DOAG conference. So thank you very much.